Okay, so it's time for another Ask Tom Office Hours session. Welcome, everybody. Good morning, good afternoon, good evening, depending on where you are. It's great to have you all on today's call. This is the second part of the raster data, spatial data management sessions. It's the follow-up to the first part, which Karin presented in August. And today she'll go into a little more detail. She'll particularly focus on how to include spatial data or raster imagery in spatial data workflows using REST. So that's going to be the main aspect of today's session. She'll also show you how Spatial Studio fits in with raster data, how we can do a little bit of raster algebra. So that's the plan for today. The housekeeping rules are as usual. If you have any questions, feel free to stick them into the Q&A box, right? Don't use chat, please, because it's a lot easier for us to keep track of your questions if you use the Q&A. And yeah, with that, it's my pleasure to hand over to Karin, who I think can introduce herself if you're not aware of her anyway. And with that, I would say, before I forget, Karin, if you move back to the previous recordings, right, I was already referring to the August session. I hope everybody knows where to find the previous sessions on the Ask Tom website. I mean, it's the website where you've registered, so I hope you get the notifications on a regular basis. The spatial and graph sessions are recorded and can all be found on that website. And of course, Karin's first part of the series on raster data, the one from August, is uploaded and available there. We'll also make today's session available there, plus additional materials as usual. And as I said, if you have any questions, feel free to ask us anytime. I'll keep track of the Q&A, but we also have Denise and Jane on the call, so they can also keep an eye on the Q&A. And with that, I would say I'll hand over to Karin. Thanks for preparing, and everybody enjoy the session.
Thanks a lot, Hans. For everybody who doesn't know me yet, I'm part of the Oracle Spatial Product Management team. Same applies for Hans and everybody else here in the panelist. So helping me with answering your questions. And yeah, I've been with Oracle for more than almost 18 years. 3 years of those with the product management team. Yeah, and I'm happy to discuss further the topic of GeoRaster or raster data in the Oracle database. And everything you see here on the agenda is available with the Oracle database. There are two things I need to note here. The topic of the GeoRaster REST API is a new feature of the Oracle database 23 AI. And then, as hopefully everybody knows about Oracle Spatial Studio, our web interface to work with spatial data. The support for raster data has been recently introduced, and I'm going to show you an example of how to load raster data with Spatial Studio and display raster data in Spatial Studio projects. The rest of what I'm going to present is available in 23i, but also in 19c. Most of you, I assume, are still on 19c. But yeah, for those who are developers among you, I think the GeoRaster REST API is a very good example for testing it out, using it in your applications, and maybe also a good reason to already move forward to the new Oracle database version. Okay, so much for the agenda. Let me start with a brief recap of what we have done in August. You probably remember that we talked about this several types of spatial data in the Oracle database. And what we are going to focus on is the topic of raster data. So raster data management for raster images delivered by either satellite imagery, drone imagery, or as gridded data. So we store them in the Oracle database where we have the support for specific raster data type or GeoRaster data type. And along with the GeoRaster data type, there are the different operations and functions to work with raster data, either working with raster data alone or to combine raster data with other types of geodata, or in general with other data stored in the Oracle database. And what we are going to figure out when using raster data is, from an analytical point of view, is, for example, what is the extent of the damage from a natural disaster. So we have either drone imagery, airborne imagery, satellite imagery from the area where a disaster took place, and this is what we are going to analyze. Or questions like, how close is a tree canopy to our utility lines, in order to make sure that there is no interference and the trees are cut to not come in contact with utility lines. And there are many other use cases and questions where raster data are used to answer specific, to get the answers for specific scenarios, and then act in conjunction or appropriately for what you have analyzed before. So what is a raster? A raster is a two-dimensional array of regularly spaced elements, which we call pixels or also cells. We already talked about where the images come from. And what you can see here is that a raster image is a matrix of those pixels and cells. But one raster image is typically composed of one or more bands. So we have an overlay of the different matrices to represent the different information in a raster. And the easiest way to understand a raster is an image that has 3 bands with the different colors, red, green, and blue, but we will come to that a little later. So here we have this overlay of the different bands with the different values for the different bands in my raster image. And as I said, can be a value, a random value, or a value that is interpreted in terms of red, green, blue color, or other types of bands, which we can actually see here. So I've checked the Landsat images and what kind of raster data you can get from there. And here are the images that are provided via the USGS service and portal. And for instance, Landsat 5 images, they are multispectral scanner images or thematic mapper images. And here you can see that they can have more than 1 or 3 or 4 bands. Here, this multispectral scanner images have 7 bands, and you see how the bands are interpreted. And the same applies for thematic mapper and also the Landsat 8 images. I'm going to use Landsat images, which have 4 bands. And I also have sample data with red, green color bands with images for San Francisco. I used the San Francisco images also in my session in August, so you might recall those as well. Okay, so bands are a very important topic when it comes to analyze raster data. There are other important terms combined with raster data, and one of those terms is pyramids. So pyramids are used to efficiently visualize the raster data. And what you can see here on the button as level 0, pyramid level 0 is the original image, and the layers on top of those are simplified versions of the original image, or every layer or every level creates a simplified version of the layer underneath. And this is used to efficiently zoom in and zoom out of raster images in order to have visual, good visual experiences when working with raster data as plotted on a map. And the simplification of those pyramid levels is done by certain resembling modes, which you can define. So either you use the nearest neighbors, so the nearest neighbors in terms of cells around another cell to calculate the average value, which is then stored in an image cell of the upper level, or you have these other resampling modes which can be used to create the new pyramid levels. And the last two terms I want to briefly talk about is blocking and padding. So typically raster images are very large images. In order to efficiently store those images in the Oracle database, we use something that is called blocking. So we divide the whole raster image into smaller blocks, which are then stored in a specific table that is needed to have the blocks efficiently stored there. This is the so-called raster data table. We talked about the raster data table in our August session as well. So we store the blocks in that raster data table, and all the blocks together form the whole raster data object. So this is the first term, blocking, and the term padding is comes from the need to have all the blocks being of the same size. So if there are parts in a block or in that are not filled with the original image, then this is padded with in order to, or the missing cells are filled with a specific value in order to have the same size for all the blocks. Okay, and how does it look like if you load raster data into the Oracle database using GDAL? GDAL is an open source tool or open source toolbox that provides different features. One of the features is called GeoRaster Translate, which is used to load raster data or in general spatial data into the different databases, or and to load raster data into the Oracle database using GDAL, you use this output format called GeoRaster. Then you specify the file you want to load into the database, and we want to store the data as GeoRaster in the Oracle database, where we need to give a connection string, which is here illustrated via this environment variable. Inside the Oracle database, there is a table called raster images, and the GeoRaster column inside raster images is called also GeoRaster here for simplicity. And then, having specified this, we have several more parameters we can use. And the first parameter is an insert statement that is used to actually store or to create an empty object in a row inside my raster images table. Then we also already apply values for the different columns inside the raster images table. So we assign an ID and we give it a name. So the source file is my San Francisco TIFF file. And by running this statement later, first, there is an object initiated, and then this object, this GeoRaster object, is filled with the actual raster image. And further down, you see more parameters which you can specify. So block size here for the X dimension is 512. The same applies for the Y dimension. We have a block band size. We have the 3 raster images bands for San Francisco. And here you also have more parameters, like we are already setting a spatial extent. And here, these 2 parameters are a reference to what I talked before regarding the blocking and also generating the pyramids. So by running this statement, we load the San Francisco TIFF file into the Oracle database, into my raster images table. The raster object is stored in the column GeoRaster, and we have blocks of 512 dimensions in both directions and in 3 bands for each block in the raster data table. So far, so good. Any questions?
So at the moment there are no questions, but it's a good time to remind everyone if there's anything you don't understand or if you want to hear more details, feel free to put your question into the Q&A box.
Okay, perfect. In order to work with GeoRaster in the Oracle database, I just wanted to remind you that there is a prerequisite for it. So as a user, you have to have the create trigger permission granted. So this is done either for an autonomous database using the admin user, or for a database system, the Oracle database as cloud service or on-prem, you use either a system or a sys DBA user to grant that permission to the user. And then as the actual application user where the spatial data is stored, you need to run execute SDO GeoRaster admin enable GeoRaster. So all of the spatial features are enabled by default except GeoRaster, which you need to specifically enable on the schema level. So just run it once, and in order to see if GeoRaster is already enabled in your schema, just run this select statement further down, where you can see if it's true, then GeoRaster is already enabled and you don't have to do anything. So just get started with using GeoRaster. Sorry, that was wrong. Okay, so much for a brief recap and a little bit more information on what raster data is and how we store raster data in the Oracle database and what you need to look out for when storing the data. Now I want to talk about Spatial Studio and the raster data support we've introduced into Spatial Studio. What I'm going to show you is actually based on Spatial Studio installation or deployment I've done in the Oracle Cloud, because I like simple things, and I typically take a marketplace image and deploy it in the Oracle Cloud, and it's up and running. So I can only recommend doing that, but Spatial Studio, of course, is also available to be used on-prem, or you can download it and install it on your laptop or your local machine. Doesn't matter. It's the same for regardless of where you have it deployed. The current version of Spatial Studio is 24.2.1. This is the one I deployed from the Oracle Cloud Marketplace. And what you can do with raster data is actually uploading raster data into the Oracle database using Spatial Studio. This is done using GDAL in the background. I already talked about GDAL, that we use it for loading, especially raster data into the Oracle database. And if once the data are loaded into the Oracle database, we can also create projects using it. So what we need to do is first, we need to make sure that we have the unlimited quota unlimited for the table space that is used by the user. I'm not sure whether this is a general recommendation when working with GeoRaster. Typically, for a non-autonomous database, we recommend setting up either one or more specific table spaces to store raster data. Of course, for the autonomous database, we have this data table space, and if you work with the autonomous database, then you need to set quota unlimited for that user. Then what I've done is I've uploaded the my raster images to a place on my machine where Spatial Studio is deployed. Then in order to load the data, GEDA is needed, but when you set it up via the marketplace, GEDA is already configured and up and running. This is what you can see here. If you open the console, Spatial Studio console, via this icon here on the navigation pane, then you can see one the tile where it says GEDA installation info. And what you see here is where the GEDA SDK is deployed. So the GEDA tools are in that directory. And what you also need is to work in conjunction with GEDA to connect to the Oracle database. We need to have the client the installation of the Oracle Instant Client, which is also provisioned when setting up Spatial Studio from the Oracle Marketplace image. So everything is fine here. So you see here the green. And then one more thing needs to be done. We need to create a file set token, which is required to access the file system from the Spatial Studio application. And this is done via creating a file set token here as well in the Oracle Spatial Studio console. And this file set token is only valid for a certain amount of time, and the maximum time is 99.9 minutes. So yeah, you can set it for less time, but this is what I used to create my file token. And then you load the raster data using that file token. And this is what I'm going to show here. For simplicity, I've just made a recording of what I've done. So the token you can see here, this is needed. Then relatively to the place where the data are, I define where to find the raster data. And then also what you can see is that GDAL info, one of the tools in the tool set of GDAL is called in order to give you information about the raster file. And here I define where to store the data, and I set in my Oracle database. And then here we go. So, and now it's calling the raster file. It's taking the raster file from the file system, running GEDA translate and importing the data into my Oracle database. And once this is done, you see here a new raster file data set displayed in Spatial Studio. Of course, if you have lots of raster files, Spatial Studio is not the preferred version of loading the raster data. Then I would use GeoRaster translate from the command line with a little bit of shell scripting that iterates over a folder or a folder structure to grab all the raster images stored there and load them one after the other into the Oracle database or in parallel, depending on how many files and how many calls you start to load the raster data. Okay, but if you want to just look at raster data and get an impression of those, that's the way you can do it. And the next thing would be to use the new data set and add it to a project. And here we go. We have created 4 data sets with raster data and add all of them to a project in Spatial Studio. And this is what you can see here. I haven't added yet the compass and zoom icon, but of course you can use all the features for maps in Spatial Studio to get a better impression. The black parts here are because of the coordinate system transformation that is automatically done between the original coordinate system and the coordinate system we use in Spatial Studio. This can be handled to give it a different color. But I let it just as it comes in the original way. Okay, so much for Spatial Studio. So you can load raster files into Spatial Studio, visualize them by plotting the data sets on a map, and then having those either as additional layers or background information. You can, of course, combine different raster data objects into so-called virtual mosaics. So a larger raster image, which can also be created using Spatial Studio and can also be loaded using Spatial Studio, which I haven't included here in my demo, but these are additional features you have with Spatial Studio as well. Okay. Any questions regarding Spatial Studio and the usage of raster data with Spatial Studio?
Looks like there was no immediate question, but maybe it's worth recapping that here through, I mean, Spatial Studio just makes it very simple to upload this kind of data, as you said. But of course, you're loading the data from a client, which is probably the only option if you have an autonomous database. But if you have an on-premise database, you can also use GDAL on the database server, which comes with the Oracle database as a sort of local installation, so that you don't have to push huge volumes of raster imagery over the network between client and database. So that would be an additional option, I think, which may be just worth keeping in mind if you have huge volumes of raster data. Any other questions or any comments or any additions, Karin, from your side?
No.
Good. Right. No. If there are no questions, I think we can move on then.
Yeah. Let's move forward to the topic of raster algebra. I already briefly touched upon raster algebra in my last session, and raster algebra is set-based algebra in order to use to manipulate raster images. And we have included raster algebra operations into the Oracle database to make it very easy to work with raster images and to analyze or and process raster data without moving data back and forth between the database and an external system in order to do those things. So we have expanded or extended the PSQL. We have extended PSQL in order to also cover raster algebra. We will see a few examples for raster algebra operators and expressions inside or with PSQL. And what you can also use is this raster algebra is combined with operators that do generic arithmetic functions, logical functions. Yeah, we will see a couple of those things as well. And typically, the raster algebra functions refer or referring to the cells. So we have a cell value-based conditional queries we can do. We also have cell value-based conditional updates we can do directly on a raster image. And we can combine it with arithmetic operations like dividing, adding, whatever you can think of. And we will also see an example for doing raster classification. Just what I said before, that we have this cell value-based operations. This is an image that illustrates exactly that point. We have the different bands in our raster images, and we cut through those different bands at a specific point, and we take the values that are related to the cell on the different bands and can return those to the function. And then we either create a new raster image or raster object from that operation, or we update the original raster object with the result of that operation we are going to do. And here is one of the first example of what we can do with raster algebra. And the first example refers to finding cells inside my raster. And I'm referring here to a raster that has 3 bands. And the 3 bands are, as I said before, these red, green, and blue bands are internally have the internal numbers of starting with 0. So we have the red band identified by number 0. The green is identified by 1, and the blue is identified by 2. And here you see the simple operations we have combined with logical operators here. So the cell value in my first band can either be can be between 10 and has to be less than 50. The value in the cell value in my second band is between 100 and 150, and for the third band, the green color is more than 200 and less than 245. So this is my condition. The cells I want to find for it need to apply to those conditions. And then what I also need to define is which is my input raster that where the condition is applied to. Then where do I want to store the result? And this is a GeoRaster 2 parameter here. And then there are several more parameters you can find described in the documentation. So for example, this is a storage parameter, and we can also run this kind of operation in parallel. And if we want to do that, we need to define the degree of parallelism. And in the end, when we run this find cell, we have the new raster image object assigned to GeoRaster 2. And then we can update the GeoRaster table and set the new object or the new GeoRaster object to the GeoRaster object in the GeoRaster table. So this is the general process, and we have a couple of more examples which I'm also going to explain. So these are is what we have already discussed. Finding cells. Then we have raster update function, raster mass operation function, classification function. For these 4 raster algebra operations, I have examples, but what you can also do is calculating the difference between 2 raster images and also overlaying rasters, and here doing more computation in terms of creating also statistics. And everything is inside the database, so you don't have to move anything back and forth. Okay, so here we have another example of finding cells. What we want to do here is based on a 3-band red, green, blue raster image. We want to find the green parts in that image, and this is expressed via this condition. So the green is the 2nd band with the identifier 1, and if we want to give precedence for green over red and blue. And what we return is the green color, and for everything else we have just a white background. And this is exactly the result you can see here. Based on that original image, we have extracted the green parts or the green values and displayed the resulting image over here. Here is an example for raster update, and it's a similar thing what we've seen before. The difference here is that we want to update the original raster image with the dominating color in the image, and this is done via this condition, which is a little bit more sophisticated or more complex, but not too hard to understand. So if the value for the red band is greater than the value for green, and the same if the red value is greater than blue, then we have a dominance of red, and the same is for green and blue. And what we give back for these 3 conditions is then a string array. We actually replace the original values with simply red, or here with green, and further down with blue. And this is the resulting image here, what you can see on the right side. Then we have an example for calculating or actually turning a red, green, blue image into grayscale. And how we can do that, we compute the average of these 3 band values and divide it by 3, and the resulting raster image is then displayed here on the right side again. So turning a red, green, blue into grayscale. And one more example that refers to classifying raster objects. What we see here is that we also also have this raster algebra expression here. We actually sum up the values for red, green, blue and divide them by 3. And if the average value falls into 0 to 63, then we assign a category value 0. If the value is between 63 and 127, then this is category 1. Then 127 to 191 is category 2, and everything that's greater to 191 is category 3. So we have 4 groups we want to represent in our raster. So we have this kind of turning a red, green, blue image into raster or a matrix of values between 0 and 2. And this is in order to represent those 4 different values, we have a cell depth of 2 bits, and the output raster is this one, and the result then is what we can see here, or I've also summed it up here in this Spatial Studio image. So these are my original 4 raster images, San Francisco 1 to 4. And these are the raster images I've created by turning into grayscale or calculating the dominant color, finding the cells, or classifying my raster images, and these are the resulting images then. I've one more example, which is very common for raster algebra. There are several indices which you can calculate or compute using raster algebra. And one of the well-known indices is the NDVI index, which you can calculate on raster images, typically from satellite images or satellite imagery, having different bands, and part of those bands are near infrared and visible red bands. And having those, you can simply calculate the NDVI index by being the near infrared minus visible red, and then divided by near infrared plus visible red. And this is expressed here in my condition for the raster or expression for the raster math operation. Since we have this indexing starting with 0, then this is band TM4, thematic mapper band 4. This is band 3, and again band 4 plus band 3, and divided the first part divided by the second part gives us the vegetation index, and the result of that calculation, this is on the right upper side is the original image, and further down we have the vegetation index calculated and expressed in value ranges between -1 and 1, and this is here the result you can see in that image below.
Okay, so you can interpret the images quite easily using the vegetation index, right? So you can say, okay, this part of the image is water, that part is forest, and we have some grass in between, or whatever, just based on that computation, which I think is pretty common. So that
based on the reflection of the raster images taken from the satellite, and the greener it is, the higher the value here it is in the index.
Yep, great, thank you.
Okay, and just as an example for a difference between raster images. So here you have the regional image, then somebody has created an image with all the trees removed. So the green parts typically removed, and then calculating the difference, you get actually back the trees. Yeah, so a lot of things you can do. The raster algebra is a very flexible concept where you can calculate all kinds of things based on the different bands in your raster data and the cell values. So just try it out. Yeah, I can only recommend it. Any questions regarding raster algebra?
So there are no questions in the Q&A at the moment.
Okay.
Anybody, any questions? If not, then Kanya, I think you can move on.
Okay. So the last thing I want to talk about is using the GeoRaster REST API. And as I mentioned before, this is part of the Oracle Database 23AI. And what I want to start with is actually how you can access the features for working with raster data. And so we have the raster data inside the Oracle database, and then we use the REST endpoints to either access or import or process raster data in the Oracle database via those REST calls, via the REST endpoints. So everything you can do using SQL, what I've seen before, you can actually also do using the REST interface. And I want to show a few examples of what you can do. The actual REST API is documented, and I've included a link to all the different documentations for the Oracle database and the GeoRaster developers guide for Spatial Studio, for the GeoRaster REST API. They are linked in one of the slides at the end of this presentation. And I think Denise or Hans, you're going to share the links as well in the chat. Okay, so this is the starting point. And from an architectural point of view, we have the Oracle database underneath with the raster data. We have a piece of software deployed in the middle tier, which is called Oracle Spatial Web Services. You can either download it or it's part of the database distribution we have when downloading the Oracle database. And there are the different services you can deploy using the geocoding engine, using the routing engine, also publishing OGC services. And the newest one is a GeoRaster REST API, which can be deployed using this Oracle Spatial Web Services. And as I said before, everything else is already part of 19C, so geocoding, routing, and OGC services, but GeoRaster is only available for 23AI. And then you have your REST clients, which then access the REST endpoints. You need basic authentication to set up your or to define your REST calls. So basic authentication means that you define username and password and give it with your REST call in order to retrieve the data you are looking for from the Oracle Spatial database via this REST interface. And the easiest way to set it up and make it running is, again, using the marketplace image, which I've done before. And there are marketplace images that use Tomcat, but you can also deploy it to WebLogic server if you have WebLogic already licensed or running in your in either in the Oracle Cloud or also using later the Oracle Database 23AI on-prem then you can deploy it manually into WebLogic container. Okay, to get started with it, just download it or launch the deployment from the Oracle Marketplace. Then it sets up a stack, and once everything is done, you can the spatial web services application is exposed via either HTTPS or HTTP, depending on what you define. You can use both to get into the spatial web services console. And as part of the deployment, we also have a GeoRaster API demo web page, which I'm going to show the next slides. But here, just an example of how to create the stack and then running the apply function for that stack. You can see here that it has the job done and everything is up and running. So in the background, there is a compute image provisioned where Oracle Spatial Web Services are installed upon, and the connection to the database is defined and already set up. So you can you have your data source already defined that you need to work with. Here, just a summary of the GeoRaster REST endpoints, and you can see that everything I talked about earlier. Here is a letter missing aggregate. It's AGGR. Just need to correct that later. But these are the packages you can run either using the REST endpoints, and everything else is quite familiar of what you can do with raster data, how you can access raster data, so you can use your REST endpoints to do exactly this one, those things. And I've included a few examples here. So as I said before, I've imported raster images for San Francisco in my table called raster images. Then I created a specific table for Landsat images, where I have uploaded only one Landsat image, which I used to calculate the vegetation index. And they all have one column called GeoRaster that stores the GeoRaster object. I've identified against the raster demo web page using the user which has the raster data stored. So it's my Ask Tom user with a password. And once I've done this, I can actually start a few things right from that place. For example, creating a virtual mosaic or listing tables, listing my virtual mosaics. And but you are free to use that right part of the demo page to put in your own REST API calls. Here, this is just list tables, and you see here all the tables having a GeoRaster column. Then on the next page, what I've done here is I have a REST call to the raster images table with searching for the raster image with the ID 1, and here is the result and the response part further down. And then another one here, we have also a REST call to a specific raster data table. So this is the raster images table, and we want to see the metadata stored for the raster object identified by 1, and it's basically what you can also see either with GDAL-info or what's then stored in the Oracle database when the raster images are uploaded. So the REST API is very well documented, and here you can use it as a kind of playground to see the results of it. You can, for certain calls, for example, for put calls, you may need to define a body to give the payload with it, but then you can just send the request and get the result back with a few more information, as you can see here further down, or a description of the resource. So some information about the image, and here a histogram from the metadata of that raster object. And I think this is the last just example of how to use the REST API. Yeah, so any more questions regarding what we have seen here regarding the REST API for GeoRaster objects in the Orca database?
Looks like everything was clear. So that little application kind you're showing here, that comes pre-installed with
that comes
the kit, right?
Yeah, exactly. That comes pre-installed. Maybe I can just briefly go to that part here. So I have this. So this is the console. Hopefully I type in my very sophisticated long password correctly. Okay, so this is just the admin console. There are no Geos web services deployed since I've set up the database and everything else from scratch to demo it here. And this is the demo page. So admin. Oh, no, I'm sorry. This is the database user, the data source I find. Then, so the hardest part is always typing in the passwords. And let me take that back. So here I clicked on list tables, and this is the URL, the call to the REST endpoint with a GET method, and here is a response. And this is how I've done this one. And just to assure you that the Spatial Studio thing is not a fake. So yeah, so here are the different data sets added to my project, and we can just hide and display the certain images or the certain data sets on the map. And how I've done this is here making sure that my GeoRaster is installed properly. Then I have this file set token, which should still be in place. So these are prerequisites. Then I have the data sets defined here. And if you want to create a data set, we can also take the data directly from the Oracle database. So you find that new GeoRaster tab here. And what you can see here is, so I want to create a data set, new data set from my table raster images. And then you can also define if you want to have a single raster or want to create a virtual mosaic of all the rasters inside. So that's something you can do, single raster, and then you go ahead and create a new data set, which you can add to your projects.
Excellent. That's great
Okay,
stuff.
that's everything I wanted to show today. What I haven't shown, since it's since the on-prem version of the Oracle database not yet out. So you can't make use of the Oracle database examples for 23AI. But once we have it, we will also have a look at how we can use Python to work with GeoRaster in the Oracle database. That's a topic for a session in the future.
Right, which brings us to the topic of upcoming Ask Tom sessions. I think you had a slide on where to find more documentation and things. Those links we already have copied into the chat, so that's all there. And there's more resources as usual, just for your reference. And then I think the last slide is on the next spatial Ask Tom office hour. Due to the holidays at the end of December, we will skip the end of December session. The next Ask Tom session is planned for January 28th. So that's the one which will be coming up next. We have not yet defined the topic, but of course we'll send it around as soon as we've decided what we want to do. Hope to see you again, all of you there. And until then, at least from my side, thanks for joining. Happy holidays. It's still a month to go, but happy holidays, everyone, because we won't have a spatial office hour before the vacation period. Have a great rest of the day or great evening, depending on where you are. Karin, any final words from your side?
We are open to receive your suggestions for topics we should cover. So if you have specific wish, want to see something specific, just let us know, and then we can include it in our planning for the next office hour sessions. Yeah, we're happy to do that. And I can only rephrase what Hans said about happy holidays. Take a rest. Yeah, enjoy time with whoever is dear to you. Yeah, and we see you in next year. In January next year.
All right, great. Thanks a lot again, Karin. And with that, I think we'll close today's session.